In this video, we're going to try to figure out how to find zeros and factor completely a polynomial if we're given some kind of information, a starting place. So for right now, we don't know enough to find that beginning value. So here we have a third degree polynomial, and we talked a little bit before. We haven't formally stated what the fundamental theorem of algebra is and written it out, but essentially what that says is we're going to have the same number of zeros as we do the degree. Since this is a third degree polynomial, then that means we should get 3 zeros if we allow imaginaries. Now, we don't really have a great way of factoring this to start with, so we're given a little hint. We're told one solution. Once we know one solution, then we can use that to kind of build and find the rest of it. So if -4 is a solution, then what I'm going to do is I'm going to do synthetic division. And if this is indeed a solution, I should end up with 0 at the end. And if it has 0 for a remainder, then that should give us at least a partial factorization. So I'm going to write the coefficients across here. We have 1x cubed. There isn't an x squared, so I'm going to fill in with a 0. And then a -28 from the -28x, and -48 from the -48. I'm going to add down, bring the 1 down, multiply by the -4 in the box. This is how we do synthetic division. I'm going to add down and get -4, multiply by the box and get 16, add down and get -12, multiply by the -4 and get 48, and sure enough, I get 0 here for remainder. This should be expected. If this did not turn out to be 0, then either this was not really a solution or we made a mistake somewhere along the way. Because that is 0, we have now a partial factorization. So we can now say our polynomial, since -4 made it a 0, x plus 4 is a factor, and the rest is going to come from these terms below the line. We're going down 1 in powers. Since we started with an x to the third, that's going to be 1x squared minus 4x minus 12. Now we're still trying to solve this. So next we can look at that x squared minus 4x minus 12, and we can factor that. This hopefully is familiar territory, so we can use our box and diamond or however you do your factoring, and I believe that's going to be an x minus 6 and an x plus 2. So now our part A, to find the remaining zeros, they are going to come from the x minus 6 and the x plus 2. So if x minus 6 is 0, then x equals 6 will make that 0. And if x plus 2 is 0, then x equals -2 is a 0. So our list of all zeros, and like again we said, in a third degree polynomial, we should come up with 3 of them. They're the -4 that we were given, and then the 6 and the -2 that we just found. And then part B, to factor it completely, we've done that. So our P of x is going to be the x plus 4 times x minus 6 times x plus 2. So let's do a little different kind of problem. I'll just give you a little bit different information. This time I'm going to tell you that f of x is going to be equal to 3x to the third plus 2x squared minus 19x, and then a plus 6. And I'm going to say verify that x plus 3 and x minus 2 are factors. So we're going to have to talk about what that means. And then also, like we did before, find all the zeros and factor. And I'll say and factor completely. So we have a couple ways we can do this. Probably the easiest way is to say that if x plus 3 is a factor, then -3 is going to be a 0. So I'm going to put negative 3 in the box. I'm going to write and I'm going to do our synthetic division again. And to verify that x plus 3 is a factor, if I can show that we get 0 for a remainder, that means negative 3 is a 0, therefore x plus 3 is a factor, and I have verified that x plus 3 is a factor. So I'm going to go 3, 2, negative 19, and 6. And then coming down, we'll go 3, negative 9, negative 7, 21, 2, negative 6, and sure enough, that verifies that x plus 3 is a factor. Now I can build on this, or I can just continue this, if I want to also show now that x minus 2 is a factor. It must divide into our original polynomial also, which means it's going to have to divide into this polynomial that has resulted from our partial factorization. So you don't have to say this, but right now what we have seen, because of the remainder being 0, is we've got a partial factorization of our f of x. It's going to be x plus 3, and then it's going to be times 3x squared minus 7x plus 2. Now one option would be to factor this, and hopefully I'm going to get x minus 2. I'm going to do it a little differently because we'll use this down the road some as well. I'm going to continue with the synthetic division and put 2 in the box here and do the synthetic division on this remaining polynomial. And if I get 0 for a remainder, then I will know that 2 is a 0, and therefore x minus 2 is a factor. So there's 3, 6, negative 1, negative 2. Sure enough, x minus 2 is a factor as well. And furthermore, here is the remaining factor. That's going to be 3x minus 1. And so to answer our questions, the zeros, so the zeros of our polynomial f of x are going to be negative 3, positive 2 that we were given from the factors, and we can solve for x here and get 1/3 is the third and final 0. We can also write the complete factorization of f of x. It's going to be the x plus 2 and the x minus 2 that we were given. And then the third factor that we found, the 3x minus 1. Let's do another example. So here we're going to say that p of x, let me change back to white here. So let's say that p of x is equal to x cubed plus 4x squared plus 2x minus 4, and we're going to be given this time that x equals negative 2 is a 0. And as we have been doing, let's find all zeros and factor completely. So as we've been doing before, we'll continue that strategy. If negative 2 is a 0, we're going to put that in the box, and hopefully we are going to get 0 at the end of this story. So we'll go 1 times negative 2 is negative 2. Add, we get 2. That's going to be a negative 4, a negative 2, 4, and sure enough, we have that that's going to be a 0. Now, the remaining zeros are going to come from these terms right here. So what I've got so far now is I'm going to have to solve x squared plus 2x minus 2 equals 0. Now, the problem here is that if we try, this isn't going to factor. So now we're stuck where we have to use the quadratic formula. Who could forget the quadratic formula? Let's see, what was it again? Negative b plus or minus the square root of b squared minus 4ac all over 2a. And so for us, we're going to get then a negative 2 plus or minus the square root of b squared is going to be 4 minus 4 times a times c all over 2 times a. And so that's going to be negative 2 plus or minus the square root of, and let's see, negative 4 times 1 times negative 2 is positive 8. That's going to be a 12. We can break down that square root of 12, so that's going to be negative 2 plus or minus 2 square root of 3 all over 2. We can split that up and call it negative 2 over 2 plus or minus 2 square root of 3 over 2. So we're going to get negative 1 plus or minus square root of 3. So to answer our questions, our zeros, the 3 zeros we get from that cubic is the negative 2 that we were given, and negative 1 plus square root of 3 is a second zero, and negative 1 minus square root of 3 is a third zero. And you can write it like I did over here as negative 1 plus or minus square root of 3. Now the factors are maybe a little bit more interesting. We're going to get x plus 2 from the negative 2. We're going to get, I'm going to do this in stages, x minus the quantity negative 1 plus square root of 3. That's going to be a second factor. I'm sorry, that's an x minus negative 1 plus square root of 3. And an x minus negative 1 minus square root of 3 for the third factor. And with a little cleanup, we're going to call that x plus 1, and then that's going to distribute and make that a minus square root of 3, and an x plus 1, and that will be a plus square root of 3. So there is our complete factorization. All right, we're going to see more of that kind of stuff. Let's try one more example here. So this time we're going to be told that our polynomial is going to be a fourth degree polynomial. We've not seen this before. So x to the fourth plus 4x to the third minus 11x squared minus 36x plus 18. This time we are going to be given, since this is a fourth degree, what we have to do is we're going to have to know two solutions so that we can do synthetic division twice. Once we get it down to where the remainder is a quadratic, we can either factor that or use the quadratic formula if we must. So x equals 3 and negative 3 are zeros, and we are going to, again, try to find all the zeros and factor completely. So find all zeros and factor completely. Okay, so here we go. We're going to, as before, we can put 3 in the box, and we can write our coefficients across the top. 1x to the fourth, 4x to the third, negative 11x squared, minus 36x, and plus 18. We're not missing any powers of x, so we don't need any zeros in there. Now, if all goes according to plan, we should end up with a 0 at the end. So there's 1 times 3 is 3, plus 4 is 7, times 3 is 21, negative 11 plus 21 is 10, 3 times 10 is 30, and negative 36 plus 30 is negative 6, and 3 times negative 6 is negative 18, and sure enough, that does work. Now, I don't want to go back to the original, because if I do go back to the x to the fourth and use my negative 3, then I'm just going to get another cubic, and I'll never be able to get past the cubic. But what I want to do is take what I have here, which is a cubic, that's 1x to the third plus 7x squared plus 10x minus 6, and I'm going to build off that, or actually I'm going to continue to kind of decompose that, and so I'm going to use negative 3, the second 0 we were given, and we should get 0 for our remainder again. So doing our second round of synthetic division, that's a 1, a negative 3, a 4, a negative 12, a negative 2, a 6, and sure enough, that is valid. That means our remaining two zeros are going to come from this polynomial, x squared plus 4x minus 2. We're going to set that equal to 0. We wish that that would factor, but sadly it does not. So that means, once again, we're going to have to go back to the quadratic formula. And so we are going to get negative b, which is negative 4, plus or minus the square root of b squared is 16, minus 4 times a is 1, times c is negative 2, and that's going to be all over 2a, which is going to be 2. So we're going to get negative 4 plus or minus, and now let's see, we're going to get negative 4 times a negative 2 is 8. 16 plus 8, I believe, is 24. That's still all over 2. We can simplify square root of 24 because that's 4 times 6, and the square root of 4 will be 2. So we're going to get negative 4 plus or minus 2 square root of 6 all over 2. We can split that up into negative 4 over 2 plus or minus 2 square root of 6 over 2. Reduce that and get negative 2 plus or minus square root of 6. So to answer our questions, the zeros are going to, there should be 4 of them, and we're going to get 3, negative 3, and then we've got a negative 2 plus the square root of 6 and a negative 2 minus the square root of 6. And our complete factorization, we're going to get, I guess I call that f of x. So let me stick with that. F of x is going to be from the 3. Since 3 was a 0, x minus 3 is a factor. Since negative 3 is a 0, x plus 3 is a factor. And since negative 2 plus square root of 6 is going to be a factor, x plus 2 minus square root of 6 will be a factor, and x plus 2 plus square root of 6 will also be a factor. All right, hopefully now you can do homework number 35.